So we have given the equation y equals 1 half x plus 3. Determine the equation if you have a reflection in the x-axis. So if it's a reflection in the x-axis, if you use replacement notation, y is going to become negative y, right? And I told you to use replacement so that you remember to apply the negative y to the whole equation, right? So we're going to have negative y equals 1 half x plus 3. If you don't apply it correctly, you're going to tell me it's negative a half x plus 3, which is wrong, because I need to divide by negative 1 every term. So it's going to be y equals negative a half x minus 3. Remember, this one doesn't have an f in it, does it? So I could have typed the original in my calculator, and I could have typed the new one in my calculator, and then I would have seen it reflected in the x-axis. And if all I have is a reflection in the x-axis, where should my invariant points be? On the mirror. Remember sticking my toothbrush against the mirror? What's the mirror in this case? What's it reflecting on? The x-axis. So that's where my invariant point should be. So if I type the original in and I type this one in, I better have invariant points on the x-axis, right? So that's if you have just a reflection, you can check. Reflection in the y-axis means x becomes negative x for replacement notation. So I'm going to get y equals 1 half negative x plus 3. So y equals negative a half x plus 3. Where's my invariant points on this one? On the y. So this one I'm going to move my 5 over first. So I'm going to get y equals f negative x minus 5. So I don't have any stretches because there's no numbers in front. I don't have a horizontal translation, so I don't have to go to GCF. I have a reflection. Do I have to do what order? SRT. There are no S's, so I can leave that. My R's, I have a reflection. It's with the X, so I have a reflection in the y-axis. And I have a vertical translation 5 down. B, what's the catch? May not even know the catch. Yeah.
The plus 3 in there will be switched.
Yes, because in order to say my horizontal translation, I told you I have to have a what in front of the x? A positive 1, correct? Or else the horizontal translations will be wrong. I said negatives, you guys might mess up. So we're going to have y equals negative f, and then I have to GCF that negative 1 out. So then I have positive 1x, take a negative 1 out of positive 3, and I get negative 3. Now my horizontal translation will actually be correct because I have a positive 1 in front. Remember? So we have to make sure that we do that. Now we can say our transformations. We don't have any stretches because we have no numbers in front. For reflections, we can say we have a reflection in the x and y axis. We can put them together. For translations, we have a vertical translation two down, and a horizontal translation three right. Number 3, we're moving a coordinate. If we're moving a coordinate, what do we have to use? Yeah.
Like the new mapping.
Yes, mapping. You got it. So we have the key point is 110 is on the graph of y equals f of x. So they're giving it on the original. Determine the image point. So they want the new point, right? Remember I told you we have to read thoroughly because sometimes they give us the image. We have to find the original, which means we have to undo what we did. So I'm going to get y equals f, x minus 5 minus 4. Now remember, mapping is the same as words. So my x, I'm going to move 5 to the right, so I have to go x plus 5. My y, I'm going to move 4 down, so I have to go y minus 4. Then I can plug in my coordinate. 110 becomes 1 plus 5, 10 minus 4, and it becomes 6, 6. This one, I have a 1 in front of my x, so I'm good. Because that's the very first thing I'm always going to look for. Is it in y equals, and do I have a positive 1 in front? Because if not, that's what I'm going to change first. So, my y is going to, I have a reflection in the x-axis which affects my y's. So I'm going to get a negative y. And then I move 12 to the left, so I'm going to get x minus 12. Plug that in, I get 110 becomes 1 minus 12, comma, negative 10, which is negative 11, negative 10. C, I don't have a positive 1 in front of that x, so I have to take the negative 1 out first before I do anything. Or I'm going to get the horizontal translation wrong every time. So I take a negative 1 out. Now I have positive 1x. Take a negative 1 out of 3. 3 divided by negative 1 is negative 3. So I'm actually moving 3 to the right, not 3 to the left. So I'm going to get x, y. I'm going to get a negative x because it's still with the x, right? Even if I take that negative 1 out, it's still with the x, correct? Because I put those extra brackets around the outside. So I'm going to get negative x plus 3, comma, y. So 110 becomes negative 1 plus 3, 10, which is 210. Number 4, we're going to graph the following transformation. So we're moving coordinates, right? There's more coordinates than one coordinate. So we're going to use mapping. We make it y equals g, negative x plus 1, move the 1 over. I'm going to get x, y becomes, the negative is with the x, so it's going to be with the x in mapping. And then I'm moving 1 up, so y plus 1. So my first coordinate is negative 6 and 3. It's going to become negative and negative 6, comma 3 plus 1. So it's going to become 6 and 4. Then I have negative 4, negative 3. And I'm going to get minus a minus 4, comma negative 3 plus 1. So I'm going to get 4 and negative 2. And then I connect. 0, 0 becomes, is that right? I feel like it's weird. 0, 0 is going to become negative 0, comma 0 plus 1, which is 0, 1. And then I have 4, negative 4. It's going to become negative 4. Negative 4 plus 1, which is negative 4, comma negative 3. Oh, that one remained invariant. It was negative 4, negative 3. It's still negative 4, negative 3. Is that true? No, it just happens to still be a point on the graph, but it's not invariant because it actually was a different point and it became negative 4, negative 3, right? So it's not invariant. Are there any invariant points on this graph? No. The moment you start throwing like a plus 1 on it, it shoves everything up, right? So it's going to throw it up. Okay, can you grab out the table that we left off on? Okay, so the fifth one down, I had given you replacement is negative 2, comma x plus 1, and y became negative y. So I would do my equations first. So I would get, and my equation is y equals f of x. So I would get negative y equals f of negative 2 bracket x plus 1. And then I would divide by negative 1 over. This is all one term, isn't it? Some people think it's different terms. This is one, it's f of something, correct? Like f of x, so it's one term. So the negative 1 just goes in front. So I'm going to get y equals negative f bracket negative 2 x plus 1. then when I go do my words, I have a horizontal stretch. I'm going to do short form because I literally can't fit it on here. Don't ever do short form. If you did it, don't do it on the test. Okay, horizontal stretch by a factor of. Will this be accepted on a diploma? No, please don't do this. What's it a factor of? 1/2, because it always flips out of the equation, right? 1/2 about the y-axis. We have no vertical stretch. We have a reflection in the x and y-axis. Please don't short form like I'm doing. And then we have a horizontal translation, 1 left. And it's correct because there's a positive 1 in front of the x, right? We always have to look for that before we state our transformation. Mapping, we're going to have xy becomes negative 1/2, because it's reflection in the y, and negative 1/2 x minus 1 to go left 1, and then negative y. The next one I gave you mapping. So I gave you xy became x plus 2 comma negative 1/2 y. What's the same? Words and mapping, right? So I would go right to words right away myself because they match. So I have a stretch on my y. I have a vertical stretch by a factor of, remembering not to short form like me, 1/2. Why does it say 1/2? Why doesn't it flip? Yeah.
It's already in mapping.
Right. And words and mapping? Yeah, the same thing. Right? So we don't ever flip between words and mapping. About the x-axis, the y is negative, so I have a reflection in the x-axis. And then I have a horizontal translation to the right, because I do what I say. So if it's plus 2, that means I'm moving it 2 to the right. Now, replacement notation is the opposite. So if I have x plus 2, x is going to be x minus 2. And y, if it's negative 1/2 y, is actually going to be negative 2y. So remember, replacement notation is actually the complete opposite of words. Even your y is opposite, right? Because you're putting it in for the y. You're not putting it into the right side of the equation. So I'm going to get negative 2y equals f of x minus 2. Then I'm going to divide by negative 2. Y equals, instead of dividing by negative 2, I told you to multiply by negative 1/2. The next one, I gave you the equation. So we said y plus 3 equals f 2x plus 2. So I'm going to need to move the 3 over. So I get y equals f something minus 3. What do I have to do with that bracket? GCF. Or my horizontal translation is going to be wrong. So I need to take a 2 out. When I take a 2 out, I'm left with x plus 1. Now, actually, replacement notation, this was in perfect replacement notation, because everything was with the y and everything was with the x, right? So my y replaces to y plus 3. My x replaces to 2x plus 2. And then words. So if we look at stretches, I only have a horizontal stretch by a factor of what? 1/2, because it always flips out of the equation. About the y-axis. I have no reflections because there's no negatives. I have a vertical translation 3 down and a horizontal translation 1 right. And And then my mapping is the same. So my xy becomes horizontally stretched by a half, so I'm going to get a half x. And then 3 down, so y minus 3. 1 right, this plus 1. The last one on this page is a vertical stretch by a factor of 2 about, what's that?
Is that like the 2x plus 1 being 1 left?
Yeah. Totally it would. That's why when you were all whispering, I said, what's up?
I was wondering, sometimes I like think it's 1.
No, you're right. Just speak it. You got this. So the x. Reflection in the x. And then I said vertical translation 3x. So no short forming, right? On tests, no short forming. So our mapping is going to match it. So xy will become vertical stretch by a factor of 2. So I know it's going to be 2y. Reflection in the x-axis. So if it's in the x-axis, it actually affects the y. And then I go 3 up, plus 3. Nothing happened to my x. My replacement is the complete opposite, right? But we also need to make sure that we put it in brackets. Because just like the horizontal translation would be wrong if I didn't GCF and have a 1 in front of my x, your vertical translation is going to be wrong in replacement if you don't have a 1 in front of your y. So x is replaced with x. That one's really easy. Your y is replaced with the flipped version. So it's going to be bracket negative a half. And then I need to have a positive 1 in front of my y. So I got to put a bracket in there when I go do replacement. So it's y plus 3. It's going to be y minus 3. In mapping, we never have brackets, right? You just multiply and then add. It's only in replacement notation where you have to have that positive 1 in front, okay? Don't go start adding brackets to your mapping. Do I ever have brackets in my mapping? Nope, you never will. So then when we do the equation, we get negative 1/2 y minus 3 equals f of x. And then I have to multiply by negative 2 first. If I want to get this into normal terms, multiply by negative 2. So I get y minus 3 equals negative 2 f of x. And then I'm going to add my 3. So y equals negative 2 f of x plus 3. Okay? I'm going to flip over. So here we have y minus 2 equals f 3 x minus 1. So I gave it with the GCF out already, right? It's in nice replacement notation, actually. So we're going to have x is replaced with 3 x minus 1. Could they say also 3x minus 3? Could they technically say that and be right? Yep. They could distribute it through. It would be the same thing, right? It would just be without the GCF out. And then y is replaced with y minus 2. My equation, I'm going to go y equals f 3 x minus 1 plus 2. So my wording, I get a horizontal stretch by a factor of 1/3, because those flips, about the y-axis. A vertical translation 2 up, and a horizontal translation 1 right. And then my mapping follows it. So xy becomes 1/3 x, and 1 right, so plus 1, comma, y plus 2. Then I give you replacement notation on the next one. X becomes 1/2 x. Y becomes 3y plus 3. So when we go to our equation, we're going to get 3y plus 3 equals f of 1/2 x. You can subtract my 3 over first. So this is the difference. In the previous page, I multiplied by -2 first, right? Because it was GCF'd out. So I have to do this first before I can do brackets, right? Because we undo dead mass. Where this one, I can subtract my 3 over first because why? Because it's not in a bracket now, right? So I'm going to get 3y equals f 1/2 x minus 3. And then I have to divide by 3. Each term, divide by 3, divide by 3, f of x is one term, and this one. So my equation is actually y equals f, 1/3, not f, 1/3, f 1/2 x minus 1. Because you have to remember to apply it to that one. So my transformations, I get a vertical stretch by a factor of 1/3 about the x-axis. A horizontal stretch by a factor of 2 about the y-axis. And a vertical translation 1 down. And then my mapping, I'm going to use those numbers, right? 1/3, 2, and 1. So I'm going to get xy becomes 2x, comma, and the 1/3 applies to the y, and then 1 down, minus 1. This one I have a reflection in the y-axis. Vertical translation 2 up. And a horizontal translation 4 right. Whenever I have words, I go to mapping right away. If it's a reflection in the y, it affects the x. So I'm going to get a negative x, and then I need to go 2 up, so that's my y plus 2, and my x I need to go 4 right, so I'm going to add 4. Now, with replacement notation, I do the complete opposite. So x is going to be replaced with -1. Remember when you have a reflection or a stretch, you're going to put it in brackets so that you have that -1 in front of your x. So -1, and then I need to move 4 to the right. So I'm going to go x minus 4. And then my y is just going to be y minus 2. So I have to go the opposite. So I'm going to get y minus 2 equals f -1 x minus 4. And then y equals f -1 x minus 4 plus 2. Next one I gave you mapping. Xy becomes 2x plus 3 comma -y. So I do words when I'm mapping. So I have a horizontal stretch by a factor of 2. Remember, we use the same numbers about the y-axis. I have a negative in front of the y, so I have a reflection in the x-axis. And I have a horizontal translation 3 right. Then to do my replacement, I do the opposite. So if I have a horizontal stretch by a factor of 2, I'm going to get bracket 1/2. Bracket, and I need to go 3 to the right, so I'm going to go x minus 3. And my y, I do the opposite, reflection in the x-axis, so it's just a minus y. Because remember, the negative 1 is the nice one, it doesn't change. So either you have a negative in front or you don't. So I'm going to get negative y equals f 1/2 x minus 3. And I divide by negative 1. Y equals negative 1 f 1/2 x minus 3. And you don't need the 1, you could just go negative.
Question about the first one, the equation, why didn't you distribute that? So it's like negative 3?
Which one?
Like the first one, the one in red.
This one here?
On the left.
Here?
Yeah.
Why didn't I put the 3 through?
Yeah, for the negative 1 as well.
Because it doesn't matter. This form is the form I want if I have to state any transformations or if I have to do any mapping. So I don't ever distribute it through unless I'm forced to. So the only way I would ever distribute it through is if you were trying to match like a multiple choice and they had 3x minus 3 and no brackets in between. Because other than that, I'm going to have to take the 3 out to answer any of my mapping or my words.
Yeah, so for the original equation, you just leave it like that.
Mm-hmm. But if you had put the 3 through, you wouldn't be wrong. It just might lead you to wrong things in the rest of the stuff. But your equation would not be wrong. Yeah. Then we have 3y plus 3 equals f negative x. So my replacement's easy because it's in the form already. Y becomes 3y plus 3. And because I would take that y, hack it out, and completely replace it, and my x would become negative x. But I'm going to change it so that I actually have it in a form that's useful for the other two. So I'm going to subtract 3 over, so 3y equals f negative x minus 3. And then I'm going to divide by 3 each term. So I'm actually going to get y equals 1/3 f negative x minus 1. And then I can do my mapping and my words properly. So I have a vertical stretch by a factor of 1/3 about the x-axis. Remember, I'm short forming just to fit in this box. If you short form, this is the moment. I'm going to bring you back to this. This is September 22nd, 9:33, recording at 28:15. If you write it short formed on your unit test, you will get no marks. 28:15. I will go back to today. I will to this point, and then I'll be like, see, you were all here. There was no one missing. Boom, boom. You know. Okay? So if you write BAFO on your test, you're getting no marks. If you write HS, no marks. If you write VT, no marks. Okay? Finished at 28:46. There, it was like a 30-second span. We got it. Okay. Then we have a reflection in, it's affecting the x, so we have a reflection in the y-axis. And then we have a vertical translation, 1 down. My mapping, my xy is going to become negative x, because reflection in the y, and then 1/3 y minus 1. Next one I gave you replacement. X becomes x plus 1. Y becomes negative y plus 2. So if I go to replace that, I'm going to get negative y plus 2 equals f of x plus 1. Then I'm going to subtract 2 over, so negative y equals f x plus 1 minus 2. And then I'm going to divide by negative 1 each term. So I actually get y equals negative f x plus 1 plus 2. So if you don't do it right, you're going to need your vertical translation the wrong way. So I have no stretches. I have a reflection affecting my y, so I have a reflection in the x-axis. And I have a vertical translation to up and a horizontal translation one left. My xy will become x minus 1 comma negative y plus 2. Then I have horizontal stretch by a factor of 1/2 about the y-axis. Reflection in the y-axis. And a horizontal translation 3 left. So I have xy becomes 1/2 negative 1/2 x 3 left minus 3, and my y stays y. When I go to do this, it's going to all flip. So x is going to become bracket. Instead of negative 1/2, it's going to be negative 2. And I told you I'm going to do those brackets, so I have a positive 1 in front of my x. I need to move 3 to the left, so I'm going to add 3. My y stays a y. So I get y equals negative, f, negative 2x plus 3. Then I have one last one. xy becomes 2x plus 3 comma 1/3 y. So I have a vertical stretch by a factor of 1/3, because the number stays the same, above the x-axis. I have a horizontal stretch by a factor of 1/2 about the y-axis. Oh, I covered up my oopsies, so that's good. By 2. Remember, the numbers stay the same, and then I flipped them. Good job, Crystal. Okay, horizontal stretch by a factor of 2 about the y-axis. And a horizontal translation 3 right. Now x becomes, it flips 1/2 bracket x minus 3, because I'm moving 3 to the left. My y becomes 3y, because it always flips when it's in this. So I get 3y equals f 1/2 x minus 3 divided by 3. So I get y equals 1/3 f 1/2 x minus 3. Then you have homework. Yes. You haven't had it in so long, but you'll be fine, I promise. You'll work through it. Okay. So your homework is page. Why are you frozen? Well, that's weird. Okay. Page. I'll write it down here. It's not letting me read. 38 onwards. Number 3. 5 to 9.